Hey everybody, Mr. Reeves back with you, and today we are looking at rates and unit rates. So what I have up here on the screen is the article from Khan Academy that I asked you to review. And in this article, or notes as I like to call them, he defines what a rate is. A rate is a ratio that compares two quantities with different units of measure. So we were talking about a ratio. Remember, a ratio is simply a comparison of two quantities, or sometimes we add a comparison of two quantities by division. A rate is a special type of ratio where the two quantities have different units of measure. So for example, kilometers per hour, right? Kilometers, 760 kilometers in 765 kilometers in 3 hours, right? We talk about miles per hour more often here in these United States of America, right? But we can have like cents per ounce, feet per second. There's all kinds of rates. Rates we often think of when we're saying how fast you go, right? Or how fast or how much something costs, right? Or an amount you need in a recipe, something like that. All right. So that's what a rate is. A unit rate is two quantities in a ratio where the number of units of the first quantity is compared to 1 unit for the second quantity. All right, so for example, if we were to take this one right here, 765 in 3 hours, that would not be a unit rate because that second number is a 3, right? But if we can make this into a 1 hour, then it would be a unit rate. Of course, that would change the rate if we wanted it to be equivalent, right? Well, what did we have to do? We had to divide that by 3, so then we would divide 765 by 3, and then we could change that to a unit rate. So real quick, if I did 765 divided by 3, 3 goes into 7 2 times, right? 3 goes into 16 5 times. And 3 goes into 15 5 times, right? So it would be 765 kilometers in 3 hours would be equivalent to 255 kilometers in 1 hour, and that would give you your unit rate. All right? So 60 minutes in 1 hour, 42 words in 1 minute. All right? And then to find a unit rate, this is funny. This is what I just did. 765 divided by 3, we get 255. So if you simply take the first quantity and divide it by the second quantity, you will get a unit rate because anything divided by itself is 1, right? So you would be dividing that top number by that bottom number, which would make that bottom number equivalent to 1. All right. When we work with fractions in just a little bit, it will be a little more clear on what we're doing there and why. Okay, so he goes through and the notes and gives you some more practice. So I'm trusting that you have done that Khan Academy material, and now you are ready to do the IXL. Got to be honest, the IXL starts off pretty easy. So skill, 7th grade skill, J5 unit rates. All right, so I don't think we're going to need a calculator or to write anything down for these ones. 15 cupcakes in 3 boxes. How many cupcakes per box? So we need to do 15 divided by 3 and get 5, correct? There we go, 5. Let me take that off of there. That's better. 12 stamps in 2 sheets. Well, 12 divided by 2 is 6. See how easy that is? Let's try skipping up to the next level. All right, 48 seats in 3 rows. Well, how many seats in 1 row? We simply divide. 48 divided by 3 is 12. Right? 48 divided by 3 is not 12. 48 divided by 3 is 16. And this is why feedback is so important, because the next time I am asked to do 48 divided by 12, I'm sorry, yes, 48 divided by, oh my goodness, 48 divided by 3 is 16. 48 divided by 4 is 12. I, of course, know that. 12 divided by 4 is 3. Look at that. They are insulting me by taking me back to such an easy problem. Okay, Let's go to the next level. You know, Mr. Reeves, if you hadn't gotten it wrong, they wouldn't have sent you back. All right? It's like flunking first grade. Back to kindergarten, Mr. Reeves. Okay, 78 divided by 13. Can you do this one, Mr. Reeves? Let's see. 13 and 13 is 26. 26, so 13 times 4 is 52. So we need a couple more. So how about 6? Yeah, how about 6? Yeah, there we go. All right, so I think the numbers are just going to get more challenging as we go up, but it's always going to be taking the first one divided by the second one, and that will give you the unit rate because that will make that second number 1, right? Because what's 142 divided by 142? It's 1, right? So we're basically finding out how many of these are in that, and that will give us the unit rate. Okay, that's how you do J5. What about J6? Okay, now we are doing the similar process, except now we have fractions. So they're going to make it a little bit more challenging, but the concept is the same. All right, so Shelly's cup of tea, not my cup of tea, that's Shelly's cup of tea. All right, that was supposed to be funny. Cooled down 1/2 of a degree in 10 minutes. At what rate was her tea cooling down? All right, now notice the answer here gives you a clue. We want degrees per minute, right? By the way, sometimes I just want to warn you, sometimes the wording in the information is different. So you can't always just find the first number and divide it by the second number, right? So I could say, for example, it took 10 minutes for Shelly's cup of tea to cool down 1/2 of a degree. And then you wouldn't do 10 divided by 1/2 and get 5. So read it carefully. That's why if you look at what they're asking for, degrees per minute, that tells us we're going to take degrees and we're going to divide it by minute. Does that make sense? All right, so many times, most of the time, they're going to give you the information in the order you need it, but just watch for that, be aware. So I need to do 1/2 divided by 10, right? Remember, when you have a fraction, dividing by a fraction is the same as multiplying by the reciprocal. So 1/2 times 1/10 is 1/20, right? 1/2 divided by 10 is equal to 1/2 times 1/10 because this is 10 over 1. So remember, when you're dividing by a fraction, you multiply by the reciprocal. So it goes 1/20 of a degree per minute. And you think about it, it's got to be small because it only cooled down 1/2 a degree in 10 minutes. Does that make sense? Alrighty, so there's our first answer. Well done, Mr. Reeves. All right, the copy machine at the library made a copy of Leslie's 3-page essay in just 1/10 of a minute. All right, we want pages per minute. All right, pages per minute. So here's our pages, 3. We're going to divide it by our minutes, which is 1/2. But 3 divided by 1/2 is the same as 3 times 2 over 1, right? And what do we get? 6 pages per minute. 6 pages per minute. So think about it. If it did 3 pages in 1/10 of a minute, all right? That's not right. Can it, right? 3 divided by 1/2 is, oh, because it's not 1/2. It's 1/10, Mr. Reeves. All right. I know Alec is like, Mr. Reeves, you're wasting more of my time. All right. 3 divided by 1/10. Did you see that, though? Did you see how your math teacher got an answer and he didn't just accept the answer? He thought about it critically, right? If it did 3 pages in 1/10 of a minute, it certainly didn't do 6 pages in a full minute, right? See, I caught my own error. All right. So 3 over 1 times 10 over 1. How about that? How about 30 pages? Right? 30 pages makes much more sense, right? That 1/10 of for 3, so 3 times 10 is 30. All right, let's skip up to the next level. All right, Camila filled up a 4-gallon bucket in 1/6 of a minute. At what rate does the water flow through the hose? Again, gallons per minute. 4 divided by 1/6 is going to be 4 times 6, right? Which is going to be 24. All right. A fraction and a fraction. Now we're having fun here, aren't we? An English teacher reviewed 2/3 of an essay in 1/4 of an hour. All right. How many essays can she review in 1 hour? All right. So we want, what are we looking for? We're looking for essays per hour, right? So the essay goes on the top and the hours goes on the bottom. So again, 2/3 divided by 1/4 is the same as 2/3 times 4 over 1. And what do we get? We get 8/3 of an essay. It says now, write it as a proper fraction, a mixed number, or a whole number. All right, 8/3 is not a proper fraction. It's an improper fraction. But I can go 3 goes into 8 2 times, 2 and 2/3. All right, so 2 and 2/3 is the answer that we are looking for. 2 and 2/3 essays per hour. Fantastic, Mr. Reeves. Take that, Alec. Ha! I'm fantastic. All right, here we go. Same thing. $20 for 5 6 of an hour. What is the hourly rate? So we want dollars per hour. Again, guys, dollars per hour. So we're going to put the $20 on the top, right? And we're going to put the 5 6 of an hour on the bottom. So we're going to do 20 over 1 times. We're going to flip that over and make it 6 over 5. Well, 5 goes into 20 4 times. 6 times 4 is 24. So $24 per hour, which makes sense, right? Because 5 6 of an hour, that's 1/6 less than a full hour. So if you take 24 and you divide it by 6, you get 4, right? For every 1/6 of an hour. That's 10 minutes, by the way. Every 10 minutes is $4. Watch this, Alec. Watch this. Ha! Okay, here we go. Finally, to skill J8, which is compare rates. We want to compare rates. Which brand is the better value? Okay, now we're going to assume a better value means less of a cost for the same unit, right? We know, don't you, sometimes cheaper is not a better value, right? There are times where you go with the cheaper one, and in the end, it's not a better value. But for our definitions here, better value means lower cost. Better value means lower cost. Did I mention better value means lower cost? All right, I did. So 2-pack for $1.74, 4-pack for $3.60. Okay, now we want to know cost per item, right? So if we take 174 and we divide it by 4, right? 174 divided by 2, or we take 360 and we divide it by 4, which is the better value? Well, this one goes in evenly, doesn't it? I happen to know that 360, so that divided by 4 is going to be what, 90 cents? So if we write it, so that would be 90 cents per pack. Okay, let me ask you this. If I do 90 cents times 2, what do I get? I get $1.80, right? So this one is cheaper. This one is cheaper. The first one is quick clean. All right, so I'm going to click quick clean, and it is cheaper. All right, lemonade. Liz squeezed 18 lemons in 6 minutes. Rick squeezed 24 lemons in 12 minutes. Who squeezed at a faster pace? Well, we have 18 and 6. We have 24 and 12. Well, 6 goes into 18, 3. So Liz was 3 lemons per minute, right? 24 divided by 12, that would be Rick. Rick is 2 lemons per minute. Well, last time I checked, 3 was bigger than 2. So therefore, we're going to say Liz gets the lemon squeezing prize. Wow, it does not go up to a higher level. See, it won't let me click over. They don't get any they don't get any more difficult. But let's see what it says. Neil and Juan scored the same number of points last basketball season. Neil played in more games because Juan was injured. Okay, if Neil and Juan play in the same number of games this season, who will likely score more points? Well, if they scored the same number of points, but Neil played in more games, what does that mean? That means Juan had to score more points per game, right? Again, they scored the same amount. Let's say they each scored 10, all right? But if Neil played in 2 games, he scored 5 points per game, right? If Juan played in 4 games, he scored 2.5 points per game. So, since Neil played more games, Juan scores more per game. All right. Last one here. Reed Middle School fall musical is a hit. Yes. Nolan is selling rose bouquets and carnation bouquets outside the school auditorium for people to give the cast members. On opening night, Nolan sold more carnation bouquets than rose bouquets, but he made the same amount of money on both. On closing night, he sold the same number of carnation bouquets as rose bouquets. Did Nolan make more money on rose bouquets or carnation bouquets on closing night? Well, wait a second. Nolan is selling rose bouquets, right? He sold more carnation bouquets than rose bouquets, but he made the same amount of money on both. All right. Well, if you have to sell more to make the same amount of money, what does that mean? That means that that item is cheaper, right? Right? Yeah? You're going to have to sell more Toyotas to make the same amount of money than you are to sell Porsches, right? You sell a Porsche, you're going to make a whole bunch of money. You're going to have to sell a lot of Toyotas to get the same amount of money. So carnations are cheaper than roses. Anyone who buys flowers knows that carnations are cheaper than roses. So, on closing night, he sold the same number of carnation bouquets as rose bouquets. So therefore, he made more money on rose bouquets because roses are more expensive. Terrific, terrific, terrific. All right, I'm going to go ahead and stop there. I certainly hope this was enough to not just get you started, but to get you through all those IXL skills. I hope after going through the Khan Academy and the IXL, you are now clear on what a rate is and what a unit rate is, how to find a unit rate, and how to compare 2 different rates. All right, have a great day, everybody. I'll see you next time.